Hello friends, my name is Akshans and welcome to CAD Academy. In this lecture we will be studying about the differential equations. Types of the differential equations which we will cover in this lecture will be, first of all, we will do variable separable method, okay? And second one, equations which are reducible to variable separable method, okay? Third, we will do homogeneous differential equations, non-homogeneous differential equations, exact, and we will do exact and non-exact differential equations, and linear and non-linear differential equations. And with that we will do last one, which is Bernoulli's differential equation, okay? So these are the general forms of differential equations which we will cover in this lecture. So up to graduate or say postgraduate level we have only these types of differential equations, so we're gonna cover these equations only, okay? So after that we will do second order differential equations also. These are what? First order differential equations. So after covering all these types of differential equation, we will move to the second order differential equation and we will calculate their what? CFPI of different types of second order or third order differential equations, okay? So we will do this for higher order differential equations, okay? We will study all these differential equations by solving the problems, no theoretical formalities, okay? So let's start. Firstly, we are doing what? Variable separable method, okay? So for that I'm taking a question which is 3 e to the power x tan y dx plus 1 minus e to the power x with sec square y dy is equal to 0. So this is the differential equation and we will solve this by variable separable method, okay? So let's do it. Let's take this thing to that side, okay? So we will have this is what? Tan y, okay? Dx is equal to what? E to the power x minus 1, okay? Sec square y dy, okay? Becomes negative and negative multiplied in this will be what? E to the power x minus 1, okay? Send the y containing terms this side, sec square y dy divided by tan y, okay? And x containing terms this side, 3 to the power x and e to the power x minus 1, okay? Now one beautiful thing which we will do now is that let's know a formula which is that differentiation of function, and here we have that function only, okay? So this is fv and this function's differentiation is what? F dash of v. So we write it as ln natural log f of v only, okay? So what we wrote, like we have f of v here, we have above in numerator we have differentiation of that function and we can write it as ln f of v, okay? So here we have what? This is e to the power x and this is e to the power x minus 1. This function's differentiation is what? E to the power x, because we know e to the power x differentiation is just e to the power x and this constant's differentiation gets to 0. So we have let's integrate both sides. So taking the constant term common, and here we have what, e to the power x minus 1 dx obviously, and integrating this side also, we have what, this thing. Okay, so this thing's differentiation is this, and this function's differentiation is this, because we know tan y's differentiation is what, sec square y. So simply we are writing 3 ln, and the function f of v is here what, e to the power x minus 1. Okay, similarly at this side we have what, ln tan y. Okay, so we have integrated the thing, but after integration we have some constant also. Okay, because if we differentiate a term we will lose the constant term, while integration we get a constant. So let's take that constant term ln c. Okay, because c is a constant and ln c will also be the constant only. Okay, so we know ln a plus ln b, which is what, ln a into b. Okay, so from here we can say ln c into tan y. Okay, this thing is like this, and here we know that ln x, 3 ln x is equal to what, ln x cube. Okay, so here we have 3, so we will write it as ln e to the power x minus 1's cube, cancelling the ln both side, and here we have e to the power x minus 1's cube, and here we have c tan y. Okay, this is how the variable separable methods problem is solved. So I have taken a complex problem and I solved that in easiest manner. Okay, so I added some different formulas into that so that you can learn wide range of things in just a single problem. Okay, so by this I am completing the variable separable method only. Okay, after that equations which are reducible to variable separable method. Okay, so separating the variables was very easy in this equation. We will do another problem where we will not be able to separate the variable this much easily. Okay, so while regarding to equations reducible to variable separable method, I am taking a question which was asked in GATE. Okay, I don't know the exactly year, but it was asked 3 to 4 years ago. So take the GATE problem, which is what, dy by dx is equal to 4x plus y plus 1 whole square here. Okay, we'll reduce this equation into variable separable equation. Okay, so how can we do that? Let's put t is equal to 4x plus y plus 1. Okay, this thing only. So we will have dt by dx 4, okay, that x gone, plus y is a function of something, so we can't take it as constant, so dy by dx. Okay, differentiation of y is what, dy by dx, and this constant is 0. Okay, because it is not the function of x. So we got a new equation which is dt by dx is equal to 4 plus dy by dx, and from where we will get the dy by dx value, this. Okay, so now we have dx is equal to 4 plus this thing we have taken as t, so t square. Okay, this has been a very simple equation. Now we can solve it very easily. Okay, so what we have, we will do the variable separations. Dt by, we will take this thing here and dx at this side. Okay, so we know that the integration of a term which is like t square plus a square, we have what, integration of this thing with respect to t, we have tan inverse t by a into 1 by a. I'm taking complex problem just to make you learn the more things in just one question. Okay, so I'm not taking a very simple problems. You will be able to do that if you learn these types of problem. Okay, so let's integrate both sides and we will have what, after integration at the both side we have 1 by 2, because we can write it as 2's square. So a is what, 2. So 1 by a, 1 by 2, tan inverse, and this t as it is, and by a this. Okay, so by comparing this formula we will get the value which is this. Okay, so and integration of x is just x, and we are integrating, so we will take a constant. Okay, so now at this time we will not take the constant as ln c, because we don't have term ln, so we can't cancel the term like we did before. Okay, so this is the solution of this equation only, but we have to get the solution of this equation. So let's take this to that side. So 2x plus 2c is what, tan inverse t by 2. Okay, and t by 2 is equal to what, tan of 2x plus 2c, taking this tan this side, now taking this 2 this side, and we will have what, t is equal to 2 tan 2x plus 2c. Okay, and we know that we have put it the t value as this thing. Okay, so this is the t value, 4x plus y plus 1 is 2 tan x tan 2x, sorry, this thing. Okay, so we generally write the solution as y is equal to 2 tan 2x plus 2c, and taking these both things this side, so minus 4x minus 1. So this is the solution of this equation. So again I'm telling that I'm taking only hard problems so that you can do easy problems very easily. Okay, now moving to the homogeneous differential equations. Okay, for homogeneous differential equations we will take a problem like dy by dx plus, not plus, is equal to y by x plus sec y by x. This is also a gate problem, and I'm not writing again and again. Generally I take problems from the gate level examination. So in this differential equation, how can we separate the variable? No, we can't. So we will do like, let's put y by x is equal to t. So what will happen, y will be equal to x into t. Okay, and dy by dx will be equal to what, first function's differentiation, second as it is, plus second function's differentiation dt by dx. Okay, and the first as it is. So writing simply it, dy by dx, we got t plus x into dt by dx. Okay, let's compare this and this. Okay, so we have t plus x dt by dx. Okay, so this is dy by dx, this is also dy by dx, so equating these two terms, and we have what, t plus sec t, because y by x is equal to what, t, so this is t, this is t. Okay, so this term written here and this term here. Now rest of the thing is like we done before, tt gets cancelled and we have x dt by dx is equal to sec t. We will take dx this side, okay, and x this side. We will have what, this thing, we have dt here, we will take sec t this side, which will be what, sec t. So what we will do, we know that sec t is equal to what, cos t. Reciprocal of sec t is equal to what, cos t. Okay, cos t dt, and 1 by x dx here. Let's integrate both sides and we have what, sin t, and here we have ln x plus a constant. Okay, so solution of this equation is like, let's put the t value here, sin y by x. We have taken t is equal to what, y by x. So okay, putting the assumption back, and here we have ln x plus ln c, or rightly we can say it as a constant k or c, which you like. So this problem done. I'm just trying to include more things into a single problem so that you get to know very much of the things in less time. Okay, now taking another problem, which is y into e to the power xy plus cos x dx here. Okay, plus x into e to the power xy dy is equal to 0. Okay, so now we will do the separation of variable, and I am kidding. Okay, so that is not possible, so we will do it like, assume this as u and assume this as v. Okay, so the term with dx, we will differentiate it with y. Okay, and the term with y, we will differentiate it with x. Okay, so now do this. So let's differentiate with respect to y. We have what, e to the power xy. Okay, so second term as it is, and differentiation of first term, which is what, only one. Okay, so second as it is and first term's differentiation plus first as it is, differentiation of second term. So e to the power xy differentiation is what, e to the power xy, and the term with y will be multiplied. This is what, chain rule. Okay, so and by differentiating this, we have first function as it is. Okay, so taking x as it is and differentiation of this thing, so e to the power xy, and term with x, because we are differentiating with respect to x, so term with x, which is y, will be multiplied here. Okay, so this is, so we did what, first function as it is and differentiation of second function, and now second function as it is and differentiation of first function. So differentiation of x with respect to x will be what, 1. So we can see that these both things are same, say equal. So if these both things are equal, we can say the equation is what? Exact. Okay, exact differential equation. So this problem is a type of exact differential equation. When we have exact differential equation, we have solution very simply, and that is what we just have to copy this thing, y e to the power x y plus cos x dx, okay, and plus, so we will take the term from here which do not contain x, okay. So here this term contains x, so we won't take this will be 0 dy, okay, and that will be equal to a constant, okay, because we are doing integration, so we will have a constant, okay. So let's integrate what we have, okay. So after integration we will get the constant, okay, so that constant should not be integrated. So now we have this thing 0, and we will integrate this by assuming that y is the constant. Now it is very simple integration. This is what y, which is the constant, and e to the power xy's integration is what? E to the power xy, and this y will get divided with this, okay. Now integration of cos x, but we, so integration of cos x is what? Is what? Positive of sin x, okay. Okay, and which is equal to what? See, so this is the solution of this differential equation. We can cancel this y, e to the power xy plus sin x is equal to c. This is what? Solution of this differential equation. Now we will see a equation which is what? Non-exact. Okay, we'll make that equation exact by multiplying that equation with the integrating factor. So this is the equation I'm writing: minus x square y square dy is equal to 0, okay. So you can see that this equation is not exact equation, okay. I'm leaving it to you. Please check that this equation is exact equation or not, okay. I'm saying that it's not an exact equation, but please check it once. So when we have a non-exact equation, what we have to do, take this term as before, and multiply x to this term and multiply y to this term. So here we have, and subtract the terms like y into square, this x get multiplied here, y plus 2x cube plus 2x cube almost. So multiply x in this, and we have what? X square plus y plus 2x cube plus y square, okay. This is what? When we multiplied x into this term, and we have to subtract second term, which is what? X into xy square minus x square, and y gets multiplied here, it will be what? Y cube. So this is the term which we call integrating factor. So after solving this, you will get what? 3x to the power 5 y to the power by x square y square, which will be what? 3x cube y cube. So this is the integrating factors reciprocal, okay. This is the reciprocal of this thing, we call it as integrating factor 3x cube y cube. So this is the integrating factor. We will multiply this thing into both term of this equation. After multiplying this thing with this equation, we will have a new equation, two by 3x dx minus 1 by 3y square into x minus 3 by 9y into dy. Okay, so you can check that this equation is what? An exact differential equation. Okay, so we know that how to solve the exact differential equation. We have done it here. So we will do like, we'll take this term as it is. Okay, and at the same time we will take the term from here which do not contain x, so this term gets discarded. So we will have 1 by 3x square y plus 2 by 3x dx minus 1 by 3y dy. Okay, let's integrate this. We will get a constant here, and after solving this you will get the answer as ln x square by y minus 1 by xy is equal to some constant k. Do it by yourself. If you are facing some problem by solving this, please let me know in comment section and I will clear your doubt. By covering more things very quickly, so I have to skip some things which I have already taught you. Okay, by doing this, by following this same procedure, you can solve this differential equation. Okay, exact differential equation. So this was the additional thing which I have to teach, and which is, you know now, that is what? Integrating factor, IF. Now I am taking a linear equation which is like, so which is like x to the power 4 y's differentiation plus 4x to the cube y is equal to x to the power 8. Okay, so this is the equation, and which is what? Linear differential equation. So we can rewrite this equation as dy by dx, this is what? Dy by dx, x to the power 4 plus 4x cube y is equal to x to the power 8. Okay, so dividing the whole equation by x to the power 4, we have this thing. Okay, so what we have now, dy by dx plus 4 by xy, okay, cancelled, and here we have what? X to the power 4. So this is the equation. So for the linear equations, how to solve this is what? Let's assume this is the thing what? X. This is the thing what? Y. Okay, so the integrating factor here will be e to the power integration of this x, okay, with respect to dx. So this is the integrating factor. So e to the power 4 by x dx integration. So we have what here? X to the power 4, because we know okay, like this. So we will do 4 and ln x, because 1 by x integration is what? ln x. So ln x to the power 4 we have done in previous problem. Okay, so it is what, e to the power, this whole thing becomes e to the power ln x to the power 4. E and ln gets cancelled out, and x to the power 4 is the integrating factor. Okay, so you can learn it like 4 by x, so x to the power 4. Okay, when the x is equal to 4 by x, this thing, then we have integrating factor x to the power 4. If it is what, 14, then it is x to the power 14. Very simple. Okay, so this is what we got as the integrating factor. Now what we have to do, integrating factor into y is equal to integrating factor into this x to the power 4 and integrate this thing with respect to x plus c. Okay, this thing which you have to learn. Okay, integrating factor into y. Okay, then this thing multiplied with integrating factor and integrate the whole thing plus this c is the solution of differential equation. Let's assume we had assumed that it is x, it is y. So writing a general form, so y into integrating factor is equal to what, integration of integrating factor into this big y, this one y, okay, into dx plus c. This is the general solution of a linear differential equation. What we have to do is we have to get the integrating factor. So this integrating factor will be multiplied at these two places. So now we can solve this equation, and we will have what, x to the power 4y is equal to x to the power 9 by 9, because it will be what, x to the power 8. So integration of x to the power 8 will be what, x to the power 9 by 9. This is a simple thing, and I am assuming that you know these things. Okay, so plus this c. So this is the solution of that equation, writing it in general form, and we will have what, x to the power 5 by 9 plus c by x to the power 4. Dividing this whole equation by x to the power 4, we will get this. So this is the general solution of this linear differential equation. Now taking another differential equation, which will be what, non-linear differential equation. Okay, so this is the equation which is what, non-linear differential equation. So what will we do here is we will divide the whole equation by the cos y. So we will have what, we will have tan x by cos y plus dy by dx here, and here we will have what, tan y by cos y, and we know that 1 by cos y is equal to what, sec y. So sec y, this thing cos y will become here what, sec y, and here we have what, this cos square x only, because we have divided the equation by cos y only. Okay, so tan y sec y dy by dx plus sec y tan x is equal to what, cos square x. So this is the equation, and we can see that this is sec y and this is what, differentiation of sec y. So while solving a nonlinear differential equation, we have to form the equation in this form. Okay, so that here we have function, let's see, f of y. So here we should have f. After getting up to this, what we have to do, put f of y is equal to t. So tan x, this thing which we have to put the value as t. So we will have what, tan x into t, and we will write dt by dx here only, dt by dx plus t into tan x here as it is, and which will be what, equal to cos square x. So this is the new equation formed, and which is what now, linear differential equation. And we have solved the problem of linear differential equation, but I will solve that for you again. So we know that we have to get the integration factor, or say integrating factor also. So e to the power this function here tan x and integration with respect to x. So this will be equal to what, e to the power ln sec x, okay, because tan x integration is what, ln sec x. So this will be what, sec x only. And now we got the integrating factor. Now we know the solution is what, t, solution is what, t into integrating factor, okay, is equal to integration of this term, which is what, cos square x, and the integration factor, which is what, sec x into dx plus c. Okay, so we have done this thing here also, like we took integrating factor into y, okay, is equal to integrating factor into that function, this one y, okay, into dx plus c. So this thing you have to learn. So that same thing we did here, like we did what, t into integrating factor, and here cos square x into that integrating factor plus c, okay, and this integration also. So this is the equation. And what is the integrating factor here? We have seen that is what, sec x, and this sec x we know that it is equal to 1 by cos x. So this will be cos x only dx plus c. So, and don't say that this sec x will get multiplied here also, because it is inside the integration, so we cannot have any relation with this before doing the integration. Okay, so let's do the integration, and we have what, sin x, integration of cos x is what, sin x plus c, and here we have what, t into sec x. So t is equal to what, sin x by sec x plus c by sec x. So we have assumed t what, we have assumed t as f of y, and what was the f of y, sec y. So it is what, sec of y, and which is equal to what, 1 by sec x into sin x plus c. We can write 1 by sec x as cos x and sin x plus c, which is equal to what? Sec y. So this is the solution of this differential equation, which is what? Non-linear. So this non-linear equation was converted into linear differential equation by this thing. Okay, so this is what? F of y, and we have what? F of y's differentiation at this side. So after that we put the value of f of y is equal to t, and we got a differential equation which is now converted into a linear differential equation, and which is what? dt by dx plus tan x t is equal to cos square x. Okay, we have put this thing is equal to t, and this whole thing is converted as dt by dx. Okay, and after that we got the integrating factor and solved it like a linear differential equation and got the solution, which is this. Now I am taking a Bernoulli's differential equation, and that is what? dy by dx plus 5 by 6x y is equal to 5x to the power 4 by y to the power 5. Okay, can we do variables separable here? No, we have forgot that, sir. Huh? Okay, no, let's leave this. And okay, to solve this Bernoulli's differential equation, here what we have, we can write this thing as y to the power minus 5. So here we have what? Y to the power minus 5, which we will say n. Okay, now this 1 minus n will be multiplied to this term, okay, and this term also. Then this equation will be converted into a linear differential equation. Okay, so what is 1 minus n? Which is 1 minus 5, which is what? 6. And at the same time what we have to do? Y to the power 1 minus n is equal to t. So y to the power 6 is equal to t. So we have to remember these two things, like this is what? Y to the power 6 is equal to t, and we have to remember these two things, this one and this one. So now this equation can be written as a linear differential equation like dt by dx plus this term, okay, and it gets multiplied by 1 minus n, and which is what? 6 into t is equal to this term 5x to the power 4 multiplied by 6. So the resulting equation is what? dt by dx plus 5 by x t and 30x to the power 4. Okay, so we have seen earlier that 5 by x, if this term is 5 by x, then we will have integrating factor as what? X to the power 5. Okay, and after that we do t into that integrating factor, that is what? X to the power 5 is equal to this term 30 x to the power 4 into integrating factor and whole integration, okay, plus c. Okay, so what we have now? 30 x to the power 10 by 10, because it is what? X to the power 9. Okay, and integration of x to the power 9 is what? X to the power 10 by 10, and plus c. Here we have t into x to the power 5. Okay, what we assumed t, that was what? Y to the power 6. So y to the power 6 into x to the power 5 is equal to what? 3 into x to the power 10 plus c. Okay, so this is the solution of the differential equation, and which we will say like it is what? Y to the power 6 is equal to 3x to the power 5 plus c by 5. So this is the general solution of this Bernoulli's differential equation. Okay, so I hope all types of differential equation. So these were the types of first order differential equation. Now we will see the higher order differential equation, and we will calculate what? CF and PI, which is what? Complementary factor and the particular integral.